Okay, today we are going to talk about perpendicular bisectors, or what's sometimes called a locus of points, where a locus being a set of points equal distance from 2 points. So if I have 2 points here, the points equal distance are along this line, or that's called the locus, and that is effectively, that blue line, the perpendicular bisector of the segment connecting the 2 points. And equidistant can often be very useful. The concept of equidistant from 2 points can help us find optimum positions for sighting services or meeting up. Can you see how it would be used to divide a plane, by a plane we mean a flat surface, in two? How it can be useful for dividing a body of water between states that surround it, such as in the allocation of fishing rights. That's especially important with countries. The key issue is formalism versus Platonism. This is theory of knowledge connection, which you'll learn about next year in regard to mathematics discussed in other TOK boxes from this course. However, it seems apropos to contemplate mathematics origins in context of rational functions. Knower bias is a key factor in knowledge production and reception. However, at first glance, it seems mathematics is immune to such biases because it is built on reason and a very high level of real-world validity. So the question is, to what extent can knowledge be free from bias? So we've thought about that a little bit in theory of knowledge, but that's an important question. And math is often thought of as being more free from bias, but it's probably not entirely free from bias. So, equidistant from 1 point. Well, the key shape that is always equidistant is the circle. And they're showing us effectively a very old style of compass here, a string that keeps a consistent distance from a single point, a circle being a shape that is known as its definition is a set of points equal distance from a single point. So we can see here in this activity, I've got points, we'll say A and B here at the end. C, AC is equal to AB, or AD is equal to BD. Same with E, F, and G, and M. All of these points, M being the midpoint, lie on the perpendicular bisector. Bisector means it cuts it in half. Perpendicular means the line is perpendicular. And there's a nice property from geometry that all points on a perpendicular bisector are equidistant from the two endpoints. Those two endpoints in this case being A and B. So some rivers and canals are borders between two or more countries, like the Akanyara River in Africa. One bank of the river is Rwanda, the other is Burundi. How do countries decide which parts of rivers or a canal belong to them? Could this create conflict between them? Yes, absolutely. They often draw something down the midline of the river or the canal and say, in a lot of cases, they probably put buoys there. You can fish this side, you can fish that side. And the big thing with fishing is the big thing with dividing them up the waters is fishing rights. Sometimes it's active rights for where your navy can practice. and be at. Those are important things. And also where it's okay for somebody else's navy to be at. Like our US naval ships can go out throughout a lot of the ocean, but there's certain points where the waters are considered too close to that country, and we can't just, park our battleships off the coast of Japan, and they think it's, oh, no big deal. They're just hanging out, or aircraft carriers or whatever modern ships we'd want to park there. We need to be far enough away that it's considered international waters. So important, the locus of points are points that are equidistant from A and B is known as the perpendicular bisector. It has to pass through the midpoint. To do this with paper, you take a compass. You put the point of the compass at A. You must go further than halfway and draw a portion of a circle. Doesn't have to be the whole circle. Do the same thing at B. Don't adjust the size of your compass. The 2 points of intersection, when connected, make the perpendicular bisector. And that perpendicular bisector, as like all lines, goes forever in both directions. So this one, find the equation of the perpendicular bisector of the line segment with endpoints 2, 3, and 4, 7. Well, first thing I need to do is find the midpoint, because I know it's going to go through the midpoint. And finding a midpoint involves averaging the x and y coordinates. I suppose I could have just looked at that. 6 over 2 is 3, or halfway between 2 and 4. So 3, 5. I know it's going to go through 3, 5. I know the slope, so I'm going to find the slope using the slope equation. That is 4 over 2. This is 2. The slope of the perpendicular bisector is then the opposite reciprocal. To write the equation for the line, I'm going to use point slope with my point 3, 5. So y minus 5 equals 1/2 x minus 3, negative 1/2 x minus 3. Key things, and I do believe that they have both the midpoint and the slope formula in your packet, but hopefully you just know those two at this point. I don't have to take the time to look them up. So example 2, find the equation of the points that are equidistant from negative 1, 1 and 3, 3. The midpoint is halfway between negative 1 and 3 is 1, 2. That's 1/2. The perpendicular is then negative 2. Y minus 2 equals negative 2, x minus 1. And they decided to put it into slope-intercept form. Fine. If it doesn't specify, it doesn't matter. Okay. So, example 3. In a thunderstorm, you hear that after you see the lightning strike, two friends who live near a beach were watching the same thunderstorm and heard the thunder at the same time. This means they must have been equidistant from the lightning strike. If a Noon's house is 9 kilometers south and 4 kilometers east of the beach, and Bonsree's is 8 kilometers south and 7 west, where did the lightning strike? Well, the key to this is going to be putting them on points. Our first one is well, let's clear this off first. Our first one is for 9, because if I put it on a graph for east, it's for -9, is down here. My next one is 8 south and 7 west. So my midpoint, I actually want to use, I want to write this out. Average the two x's, which means add them up and divide by 2. Seven is -3 over 2, -1.5. Now I'll find the slope. That becomes +1 or -11. The perpendicular slope is then going to be 11. And my equation for the line is that. And there we have that. I do want to show you something quick in GeoGebra about how to use perpendicular bisectors, and this is going to be important for what's next. So if I go to geogebra.com, let's just go to it, or geogebra.org, and I hit Start Calculator, that can give me a graph, but I probably want to do geometry. There is a way to put a grid on this if you want. So I've got A and B. I can make circles and construct a perpendicular bisector this way. I can take the segment tool, connect them, and take the circle tool. The best way to do the circle tool with something like this is just to go all the way between the two. You click at the center, go to the outside. I'm going to need to zoom this a little smaller. I'm going to construct a point here at these intersections. Be careful. If you're not careful, it won't put them on the intersection. And then I'll construct a line through these 2 points. If I click on that line and go to settings and click up here on the color tab, I can change the color if I want. There's my perpendicular bisector. It does go to the midpoint. Some nice useful things to do here are if I clicked on the more tools here, measure distance. We can see that that was the midpoint. We can see that those are equal. If I create any other point on here, I can see that these are also equal. And one of the cool things with a program like GeoGebra is I can just, if I created these all with correct points of intersection, I can drag it around and everything still stays the same. Okay, so that's creating a perpendicular bisector. One thing that's going to be really useful here is also taking a triangle Right. Now, GeoGebra you can save if you create a thing. I'm just going to clear this, but if you create an account, you can save things. This one I don't need to. So I'm going to create a triangle. And instead of going through the work of doing that by hand, I'm going to create what's called use the perpendicular bisector tool. Under construct. So to do this, I hit the perpendicular bisector tool and I'm clicking on the 2 points that I'm bisecting. This creates a point here called the circumcenter of the triangle. And the circumcenter of the triangle is going to be the point at which is the center of a circle that goes through all 3 points. So I really only needed 2 perpendicular bisectors. The third one will intersect at the same point. The beautiful part is if I do this with the perpendicular bisectors, no matter what that point is, it will always be the circumcenter. If it's actually on this right there, that's a right triangle. I think D is close enough. Let's see what happens when I measure my angle. To measure an angle, you have to do like the three angle, like CAB or BAC. It's close. I apparently don't have it dead on. But if it's actually dead on, this point of circumcenter will be on the hypotenuse for a 90-degree angle. So that is 3.5.